I'm very glad to be here, have a presentation for all of you. I have been in this class 5 years ago when I'm the doctor's student. And I'm just wondering, maybe some of you are wondering, why I'm here, why I'm joining some boring classes like radiation protection. I just want to use the XRD, then finish my experiment. And someone asked me, why do you do your experiment like this one? I will always say, my professor said, I just do that. So I don't know why I do the experiment, and I just need to finish that, use the XRD. But after I working in Institute of Nuclear Energy Research, I realized the radiation protection is very important for all of you. Even you are out of school, when you are working in the society, it's very important for you to have some concept of radiation protections. So I'm here for the 3-hour lectures for you for the radiation protections, but I will emphasize that it's just an introduction. Very complicated theories and concepts for radiation protections. So I just kick off those complicated ones and introduce you some useful and simple concepts. So then I'm sure my Chinese is much better than my English. So some parts I will repeat again in Chinese for the local students. And don't hesitate to interrupt me if you have any questions. Just interrupt me and raise your hand. Okay. So my outline for this lecture is about, I have an introduction of myself and then the source of radiation. I will introduce you where the radiation comes from. It's all around us, and you will know where the source and you can protect yourself. And then the protection from radiations. We will start in 2 aspects. First aspect is regulation aspect, and the second part is principles and self-protection. For all of you, the regulation I think is not familiar with because it all written in complicated words and it's very hard for you to realize. But it's very important for you to know some regulations, especially in Taiwan. All around the world, our regulations for radiation protection is different, especially in like USA, like French, or like Taiwan or Japan. So you need to know the regulation in Taiwan, and you don't use the regulation in USA and they say, yeah, it's acceptable, but maybe not acceptable in Taiwan. And also for the principles and self-protection, it's the very most important part for this one, more important than regulations, because principles is, the concept is installed in your brain. So if you have that concept, it's very useful for you and do your self-protection. Then I will introduce some nuclear power plants. What's the principles for the nuclear power plants and how they generate electricity. And as you know, there are several accidents around the world, especially 3 major accidents. The most recent is Fukushima power plant. I will introduce some of the videos for you, but I believe you all saw those videos on YouTube or other media players. So just introduce this part for you. Let's say the radiation will be properly used, it's useful, but not. It will cause lots of consequences and accidents. And also for your XRD operation, I will introduce some laboratory radiation safeties for you in your lab, not also for the radiation operation. Also, when you did your experiment, you can follow the principles for you to keep you safe and get your master degrees. So I will introduce. Dr. Liu has introduced a little bit. I'm now the associate researcher in Institute of Nuclear Energy Research. I belong to chemical engineering divisions. Our division are focusing on waste management, especially radioactive waste management. So for the INER, Institute of Nuclear Energy Research, we accept lots of radioactive materials from around Taiwan, like the radioactive concrete, like radioactive substances. It will be transferred to INER and will be safely stored in there. But you know, we have limited capacities, so lots of waste need to be need to be treated, especially radioactive liquid waste. So I got my master in chemical engineering in NTUST and doctor in material science and engineering. So I'm very glad to be here again and come back home, have a presentation for all of you. So I listed some projects I participated at INER. The second part is my major tasks in INER. It's a molecular 99 radioactive waste water treatment. Molecular 99 is the daughter nucleus from the TC99M. It will be used when you go to hospital, have some diagnosis for your cancer. You will be injected the TC99N. Then the daughter nucleus is multi-99, molecular 99. The half-life for the molecular 99 is more than 1,000 years. So you will be still there until you die and until your grandson dies. So we have two types. It's inorganic and organic types. Other than nucleus, there's still nitrate ions and mercury ions in that. But we have removed all the radioactive nucleus from the wastewater. So there's still nitrite and mercuric ions in there. But it's not an emergency case anymore because the radioactive once the radioactive arm removed, the wastewater can be safely stored in our institute. So for the later part, for the nitrate and the mercury ions, we will treat that step by step, not so emergency. And the first project for me is the removal of uranium and fluoride separately from red wastewater. It was stored in our institute for 20 years because the history in our institute, we want to build some nuclear bombs 20 or 30 years ago because we want to get China. So in 30 years ago, we just want to have nuclear bombs in our institute. So those are left residents for the waste. For the uranium, they need to separate it out, removal from the wastewater, then enrich that, have the uranium bomb. So we use the chemical reduction method to recover uranium and fluoride separately. Totally, we got 7.2 kilograms of uranium. Then it was stored in our institute, but supervised by the IAEA, International Atomic Energy Agency. It belongs to United Nations. So it will be supervised, inspect for several years. Then we have lots of projects from nuclear from Thai power companies. For that one, engineering evaluation of SPU, stretch power upgrade project for the nuclear power plants, for our first and second nuclear power plants. And you will ask, what's the stretch power upgrade? It means we want to upgrade 100% capacities to 104.5%. So 4.5%, we want to increase the capacity to that level. But people will concerned about the safety. So we need to assess the nuclear power plant again to make sure the RPV, the reactor, and the concrete will be adorable and will be accessible for the power plant update. And also, I will have this introduction in the later part for our Jinshan nuclear power plant, it's the first nuclear power plant in Taiwan. It will be decommissioned because it is 37 years old. So after 40 years operation, it will be decommissioned. So I will have a discuss for that. Then the second part is our source of radiation. I will introduce that natural radiation is everywhere. If you want to live on the planet, you will get the radiation from the natural, from the environment every time when you are alive. So most of part are from cosmic, from the space, and from plants, and also from radioactive soil and rocks and random. Especially this one, radioactive soil and rocks. If you analyze the radionuclides in the soil, you will find most part of that is from K40, potassium 40. It has lots of K40 in the soil. So you will receive the radioactivity when you are sit on the ground. So but don't so worry about that. You are still healthy now. So for the natural radiation, you don't just need to care so much. Especially you can see that radioisotopes such as PO210, C14, and K40 are naturally occur within your body. So when you want to digest or eat some food, it will naturally occur in your body. And especially for the K40, it will include in lots of foods like red meat, beef, pork, and white potatoes, carrot, bananas, lima beans. Lima beans is like this, and Brazil nuts. So just don't worry about radiation. Your body has God made to protect from that. So I need to explain in Chinese again. 这边要跟大家介绍，就是辐射呢是无所不在的，就是你只要生活在这个地球上呢，你就会一直接收到辐射。像现在大家都这么常用电脑跟手机，这一些的电波都是会造成你身体会接受一些辐射。那来自外太空的一些太阳的活动啊，或是一些外太空的辐射，还有这些电缆，都会造成你的自然辐射。And I will introduce that this part is the percentage of the background radiations. Most part is from radon gas from the ground, and you can see that the artificial sources are like 1/4 part of the percentage, and artificial that is nuclear power plants is like this. So it's a very small percentage of nuclear power plants consists in the radiation background. Okay, then you were wondering in Taiwan how many doses you will receive for you. From the analysis, is the natural background radiation is about 1.6 millisievert in Taiwan, and all around the world is 2.4 millisievert worldwide. So annually, you will get 1.6 millisievert per year for your body. And I will introduce some videos for you to demonstrate you how many radioactivity you can eat for you. And this one is you can see that 1.6 millisievert per year is like here. So if you want to go back to your go back to your country by airplane, if from Taipei to American like LA or San Francisco, you will get 0.1 millisievert. So when you fly back, you will get 0.2 millisievert. So this airplane radioactivity you will eat is about this. And you can see that if you smoke, please quit. Because if you have 30 cigarettes every day, you will have a 30 millisievert per year for your radiation reset. So it's almost 10 times higher than your annual radiation reception. So just quit smoking. Then for higher altitude radiation areas, they will get higher natural background radiations. So here it will tell you how many years you can eat for those meat. 1 year, probably 1 millisievert per year. And for the employees, I will tell you detailed in the regulation part. It's about 20 millisievert per year. But like me as the employee workers, when I'm surveyed in the nuclear power plants, I usually got 0.1 millisievert per hour. So it's a very low radioactive. Then if you have 1 to 2 sievert each time once, you will feel nausea or vomit. Then if you got more than 6 sievert, you will be fatal. But this part is very rare. 这边我再跟大家强调一下，就是如果你在台湾，你每年会吃到 1.6 毫西弗的一个剂量，但是如果你从台北飞到美国西岸一趟的话呢，你就会吃到 0.1 的毫西弗，那你回来你就会吃 0.2 毫西弗。那如果你飞更远的话，你就会吃更多。那如果你有吸烟的话呢，请把它戒掉，因为如果你一天吸30根烟呢，你就会吃13个毫西弗，所以说远比你每年自然吃的还要多很多。那这边下面呢，就是跟你讲，一天一般民众大概就是限制就是一个毫西弗，但是如果针对辐射工作人员部分呢，每年可以有20个毫西弗可以吃，但是就我去电厂巡回这么多次，一次都吃不到1个毫西弗啦，所以说不用担心这个。但是如果你一次吃了很多，例如你吃到6个毫西弗，6个西弗就是6000个毫西弗，你可能就会死亡。但是这个事件呢，很少发生。And this part is for your comparison for you. It's the annual radioactivity you will got. So you can see if you want to diagnose for your cancer or you have some problems in the hospital, you will have some XRD scans. It's much more higher than the annual dose you will get. And okay, I will introduce radiation. With some academic nouns for that. Radiation is energy that comes from a source and travels through space and may be able to penetrate various materials, of course. So, like the non-ionizing 非游离辐射, there are types of radiation from light, radio, and the microwaves. They are non-ionizing radiation. And for the ionizing radiation, it's produced by unstable atoms. And unstable atoms have an excess of energy of both. So for the background, most part of them are non-ionizing. So from the sunlight or from the radio waves or from microwaves, they are non-ionizing. So they are not so harmful for your body. But for the ionizing radiation, it's very harmful for your body if you expose to them too much. So radiation can also be produced by high voltage devices, like you will be operate the XRD machines. You are artificial machines, so you need to be careful about operating of X-ray machines. 辐射呢有分成2种，游离辐射跟非游离辐射。那非游离辐射主要都是大自然界产生的，像光啊、波啊这些 microwave。那游离辐射才是你们需要特别注意的。但游离辐射呢，大部分都是现在看到的都是人为的，所以说这个部分你只要注意是人为的就可以了。The same. Okay. And atoms, I think you all know that from your chemistry classes. Atoms with unstable nuclei will be radioactive, like hydrogen. It will be treated again, so it is radioactive. And in order to be stabilized, those atoms will give off or emit the excess energy of mass. So these emissions are called radiation. So those kind of radiation are electromagnetic, like light, and particulate, like mass given off with the energy of motion. So there's two types for radiation, electromagnetic and particulate. Gamma X-ray, gamma radiation X-rays are electromagnetic radiation. For the particulate, it's a beta and alpha radiation. So I think it's very complicated for you to understand. 辐射呢，就是它有两种，一种是波的，一种是粒子的。那波的部分呢，就是它是伽马射线跟 X-ray 呢，它就是波，它是波这样出来的，它的穿透力很强。但是如果它是粒子的，如果是阿尔法或贝塔粒子呢，它的穿透力就没有那么强。那我们讲，如果辐射防护呢，就跟能量传递的方式很有关系。所以说你要用它的辐射出来的方式呢，去做你的辐射防护。Okay, here's the details for the alpha, beta, and gamma. For the alpha, it's the fast-moving helium nucleus. It will be stopped by skin or paper. So your skin and one paper will stop the alpha nucleus. But I want to emphasize, the alpha will be easily stopped by paper or by your skin. But if you get that inside your body, it will bump your inside very hard because it's very heavy. It has two protons and two neutrons in the alpha particles, not like beta. Beta is the electron, so electron is very light. If you eat alpha-related foods, it will not damage you so much because you will digest it outside your body very quickly. But if you eat alpha-contained foods, it will harm you very much. But for the alpha, it will be easily protected from you. You can get your paper mask or just have some basic protection for yourself. You can prevent the injection of alpha foods. But for the beta, it's electron ejected. So it will penetrate 1 to 2 cm of water or human flesh. But it will just start by yourself. So it will start by aluminum plate. But for the gamma, like X-rays, it's the proton, so it's very high energy radiation. So it will only stop by dense materials. For the dense materials like lead, PB, or concrete, so it will only stop by them. And 我这边再讲一次中文，就是粒子呢有分成阿尔法、贝塔跟伽马。那阿尔法呢可以很容易被质挡住，所以说它就是氦的原子核，它的能量很大，但是它很容易被挡住。但是它如果吃进去你体内呢，它因为它力量很大，它质量很大，撞你的时候也会很痛。所以说阿尔法呢现在就是电厂跟一般大家在做辐射防护最防范的就是阿尔法。如果这个物质含有阿尔法呢，就要特别小心。但是如果贝塔的部分呢，它是带负电，它是一个电子，它穿透力很强，但是呢，它也可以很容易被挡下来。但是伽马跟 X 射线呢，它就很不容易。例如，它要挡下这个强度呢，它可能要有10公分的铅，或是这个水泥墙，它可能勉强才可以减弱它的身体。像这个 X-ray 呢，它可以直接穿过你的身体。So for the radiation doses, you must know the basic doses for you, then you can realize how large is that. So it's published by International Commission on Radiation Units and Measurements, like it's ICRP. But when I'm figuring out what I will put here, I just emphasize these two parts. It's a Curie for the conventional symbol systems, and SI unit will be Beck or Sievert. And 1 sievert is 1,000 millisievert, and 1 millisievert is 1,000 microsievert, and 1 sievert is 100 rand. I think it's not useful for you. You just realize annually you will get 1 to 2 millisievert per year. Then you can realize how radioactivity or how how strong is the radioactivity. And annual effect is 1.6 millisievert per year in Taiwan. Okay, so from the protection for radiation, we will start from the regulation part. Okay, the regulation part is the most boring because I will introduce some acts. I think for the researchers we have that. They have lots of difficult languages, and you don't always realize what they mean. And for the most important part of our XRD introduction, we will use the Ionizing Radiation Protection Act, 游离辐射防护法. This was effective from 2003, so it has been for a long time not revised. So it's in compliance with ICRP 660 and IAEA 115 report, especially for this one, ICRP 60. It was published by the IAEA, so it will be widely used all around the world. And in this report, it will tell you their research from the patients or from the experienced people, like the World War II survivors in Japan. They will investigate them what they have, like what kind of illness they have. Then they will have the conclusion for the ICRP for the radiation protection. And also for the IAEA is a 115 report. So it's also tell you how many patients they are surveyed. Then they have some conclusions for you. So we, according to the ICRP 60 and IAEA 150, we have our Ionizing Radiation Protection Act. And have lots of acts, like the enforcement rules for the Ionizing Radiation Protection Act, 游离辐射防护法施行系的, and safety standards for protection against ionizing radiation, 游离辐射防护安全标准, and lots of, it's more than 20 acts, regulations to protect you from radiation. So I don't tell you all of the acts here. I just pick out 3 very important acts for you. You just need to realize these 3. And for the Ionizing Radiation Protection Act, Article 3, the authority is AC, and the Article 4, there are exemptions for you, like they do not apply to naturally occurring radioactive waste and material background radiation. So those radiation or naturally radiation will be exempt from the act. So exemption, like when the radiation source poses no radiation safety hazard, it is exempt from this act. Easily to say, it's XRT machines and XRT machines in the hospital and also in universities for your experiments. Those machines are exemptions for the act. 我这边再用中文讲一次，就是这防护法呢，里面详细强调了游离辐射要依据的哪一些，例如第3条，主管机关呢就是我们的行政院原子能委员会，那它有排除对象，就是自然辐射跟天然放射性物质呢，跟背景辐射造成的暴露呢，不适用本法。所以说，你不管天然，你每年吃多少呢，你都不能用你吃多少量去跟原子能委员会说你吃那么多量，你不应该吃那么多量，那是没办法，那是天然辐射。那53条呢，它就是有豁免，辐射源产生的这个辐射如果没有安全顾虑呢，就可以豁免。例如在医院或是在教学单位这一些 XRD， 它是医疗用的跟做实验教学用的，所以说它也是可以豁免，但是不代表你操作的时候是可以豁免。Okay, then for the Article 5, safety standards, we tell you that in the last 3 parts. It's the 1991, the ICRP 60. Then recent years, 2007, is the ICRP 103. So you will ask me, why don't we just revise our act to follow the ICRP? It's very difficult. when the ICRP 60 comes, is ICRP 26. But from here to here in Taiwan, it takes 10 years. So I think in 2017, we will follow ICRP 1103. So the regulation is very slow, and the authorities need to figure out what is important in our country. So it's not easy to follow the ICRP 103 in two years. 所以游离辐射防护法第5条规定呢，它的安全标准呢，就是它的辐射作业的铺路呢，应该要参考 ICRP 最新订定的游离辐射安全防护标准。在2007年呢，这一条已经出来了，但是呢，我们要 follow 这一条，可能还要经过10年。因为我们 ICRP 60呢才刚从这边过来而已，所以说我们还要花，尤其是核能研究所要花很多时间先去研究 ICRP 103跟60它的差别在哪边。那我们里面已经有报告过了，它的差别其实不多，它把个人剂量率呢稍微往下降一些。Okay, and the Article 14, the age limit, pregnancy and accident training. So I will ask if someone under 18 here. Is anyone under 18? I think no. Yeah. If anyone pregnant, yeah, if you are pregnant, please tell the operators because you cannot use the XRD machines for your own. So for the persons engaged or participating in practice should be at least 18 years old. But for the teaching or occupational training, you could be when you are 16 to 18, you could be use the XRT machines for the teaching or occupation training. But under 16, you are not allowed to do those experiments. So the female workers, if you are pregnant, you need to reinvestigate your workplace to make sure you got acceptable radiation for your own and for your babies. 所以这边14条呢，就是讲到年龄限制，你至少要18岁呢才可以去做游离辐射防护相关的工作。但是如果你是16到18岁呢，有关教学或是职业训练呢，你还是可以接受，你还是可以操作游离辐射的。但是你低于16岁呢，是禁止做任何游离辐射相关的一些工作。那如果你是女性，你有怀孕呢，你要重新告诉你的雇主，然后你要重新检视你的工作环境是否会让你接收到太多的游离辐射。Okay, Article 14. So it's the same. And for the employees should conduct necessary education training for protection against and prevention of radiation accidents. So like you, we just need to tell you how to protect from the radiation, and you need to tell that for your coworkers or colleagues. And the education training mentioned in last paragraph is obligatory for radiation workers. So it's necessary, not an option. So for the Article 44, okay, if you are not follow that, you will get fined for those numbers, for those money. 所以游离辐射防护法14条里面还有强调，就是雇主如果针对在职的辐射工作人员，一定要定期做他的游离辐射的一些教育训练，并保持记录。就像我们今天这个都是要做记录的。那对于前项的训练呢，有接受义务，那就是代表你不能选择，你一定要去做。那如果你没有做呢，你就会被处以罚锾，然后停止作业。Okay, yeah, still. Okay, this is another act. The Enforcement Rules for the Ionizing Radiation Protection Act. So that's why I'm here. You have at least 3 hours of training per year, and 1/2 of that could be conducted in video tapes or compact discs. I want to use this method, but I don't find any appropriate CDs for you, so I just need to speak by myself. Okay, it's the regulations. So I don't think you need to know so much. The radiation source will be limited by the regulatory control. So if it's not cleaners, it will be reused or recycled. But if it's not, it's a source, it can be exemption. But if it's not those two options, it will be controlled by a regulatory. And natural background is not controlled. Okay. Okay, so the exemptions. So based on those acts, I do not find the English name for those acts, so I just mark that. It's a 辐射源豁免管制标准. So there's no English for that regulation. So like clocks and watches, like that one, if some of you maybe wear those watches, it consists of tritium. So it's a pure beta nuclides. So it's an exemption to 9 orders back. So maybe you want to get rid of those watches. So for the instrument emits radiation, if radiation less than 1 millisievert per hour in the distance of 0.1 meter from the surface of the instrument. So it's easy to say if there's one machine like this one here, it's 0.1 meters from you, the radiation you get could not exceed 1 millisievert per hour. So 我再用中文讲一次，就是如果是英文讲久讲中文会有点奇怪，就是如果这个游离辐 XRD 或是 X 光呢，它在你前面0.1公尺处，你在这边吃到的剂量率呢，不能超过1 microsievert每小时。如果超过1 microsievert每小时呢，它就不能被豁免，它就要列入管制。OK。So many acts. Safety standards for protection against ionizing radiation. So the Article 4, Article 7. So the dose limits, this slide is the most important part in here. But I don't know for those students, if you are occupational radiation workers, I do not know. But if you are the workers, in 1 year you could not exceed 50 millisievert per year. In 5 years, you cannot exceed 100 millisievert. So easy to count. 1 year, you cannot exceed 20 millisievert per year. So for your length of eyes, 150 millisievert in a year. And for your skin and your extremities, for your foot and hands, 500 millisievert. So your eye is very strong than your body. So 我再说一次，这个是今天比较重要的，就是辐射工作人员的暴露剂量呢，每年都会受到限制。就是他一年呢，单年不能超过50个 millisievert。那5年内呢，5年加起来总和不能超过100个 millisievert。所以说你简单算一下呢，就是一年呢，最好不要超过20个 millisievert。但是如果你吃到20个 millisievert，其实那个量已经很恐怖了。就是你是穿着潜水装跳到燃料池里面游个1小时才会吃的剂量，所以应该不会有人跳到燃料池里面去游泳。Okay, then Article 12, the annual dose limits to the public. So I think most of you are public. So the annual dose rate is 1 millisievert per year for you, and for your eyes is 50 millisievert, and for your skin and foot and feet, and 50 millisievert. But I do not know how to count 50 millisievert and 50 millisievert. Did you put those meters on your eye? So it's very difficult to measure. But for the 1 millisievert, you can have those meters for you. Okay. We go through the most boring part of regulations. So now we start the principles and self-protection for yourself. I think it's important for you to have those concepts and principles. And you must know that signs. If you see those signs, it's magnet and trefoil with yellow background. I think like this. It's radioactive. And IAEA and the ISO published in 2007 is about this. if you see this, I think, of course, it's a dead man, and you need to evacuate, and there's radiation. So if you see those lines, just know there's a radiation places, and be aware of radioactivity. So it's the same. I need to speak in Chinese. 这边呢，请大家注意一下，在任何的辐射源，就是它可能是固体射源或是液体射源，它外面都会贴这种警告标语，就是这一个辐射的，然后它会警告说，哦，它可能要由合格的人员进行操作这样。Okay, so the most important methods for you have the principles is ALARA, as low as reasonably achievable. 中文叫合理易低。It's very important principles for you. The explanations is like this: radiation safety principles for minimizing radiation doses and releases of radioactive materials by employing all reasonable methods. It says if you want to operate the radiation materials, you need to minimize the radiation doses for your person and use reasonable methods. For example, if there's some radiation material drop on the ground, you cannot say, I just leave there, I do not treat it. It's not a reasonable method, but you need to decide which kind of method you need to use to get the material up, put in the boxes. So the reasonable method is you can grab by your hand and then put in the box, or you can grab that with some materials or some facility gadget with you, put in the box. So ALARA is very principal methods for the radiation protection. 所以这边呢讲到合理易低呢，就是你如果要处理放射性的一些东西呢，你就是要减少你的辐射线的剂量的暴露。那要减少剂量暴露呢，用你觉得最容易的方法，或是最简单的方法去做，这就是 ALARA 合理易低的一个原则。So mitigation of external radiation exposures. So there's external, and later on we will introduce internal radiation. So to reduce the external radiation exposures, there's three. One is time. The second part is shielding, and the third part is the distance. The time, minimizing the time of exposure directly reduce radiation dose. So if you know there's a radiation material there, just don't expose to that so much time. Just keep it away. Then the shielding, if there's materials there, just use the absorber materials like gases. Then this is for the beta particles, and then PB for the X-rays and gamma rays in effective ways to reduce radiation exposures. So you can put some objects between you and the radiation materials, and the distance, keep it away, because doubling the distance between your body and the radiation source will divide the radiation exposure by a factor of 4. So if you doubling the distance, the radioactivity will be 1/2 of the original one. 这边很重要，所以我再讲，用中文讲一次，就是如果你要减少体外暴露呢，最重要的3个就是时间、屏蔽跟距离。那时间的话呢，就是减少跟他接触的时间，这很正常，你就不要跟他在一起。然后再来呢，就是增加 shielding， 就是你跟那个辐射源之间呢增加，例如增加水泥墙、增加铅屏蔽，都是可以减少你辐射暴露的一个机会。再来就是距离，你离它越远越好。所以说距离你只要达到了 double 2倍的时候呢，它的剂量率就会变成只有原来的1/4。所以说这3个时间、屏蔽跟距离呢，是一个最好的 ALARA 的一个方式。Okay, so if there's a radiation sources here, just reduce your time and do what you do, then leave. Then increase the distance. If you increase the distance, the radioactivity will be reduced. And for the if you need to operate that, set the shielding. Okay, and mitigation of internal radiation exposures. Like we say, internal, especially for the alpha particles, just to keep the alpha particle material away in case you digest it. So get hygiene techniques that prohibit the consumption of food and drink in the lab, like this. I think no food or drink in the lab. No, right? You will drink or eat some hamburgers in your lab, I think so. So always in my lab, it's not so clean because students do what they do in the lab. You just ignore the sign. But from now on, just be careful. Food and drink can be contaminated by the radiation materials. So if you drink or eat the food, you can maybe have some radioactivity in you. You will be Hulk or Spider-Man. Okay. Then the frequent swipe surveys and lab area monitoring of work areas. Then, like the professor will say, just clean our lab. Then in 3 days later, it's almost the same. Yeah. So just swipe and survey your lab and control contaminations. So just be aware of yourself and tell your colleagues about the contamination materials or toxic chemicals. Just put that away from your office. Okay, then I think use the fume hoods for materials which would be airborne, like vapors, dust, and aerosols. So do the experiment in the hood, but just don't put the experiment there, then go away. Check that in half or 1 hour, in case it will be exploded. So use proper protective equipment like the gloves to protect yourself or masks to protect your face. And this one is the tape made of. It will be sticky to your feet. So in our radioactive lab, it will be put on the ground. So when you walk by, the dust or particles will be left on the tape. So it's very useful for radiation protection. And also for X-ray aprons like this, it's for X-ray machine operators to protect your heart and protect your body. And also use the X-ray lead barriers. This one is the glass made of lead. So you can get behind the barriers, then see what happened through the gases. So some facilities you will have some lead bricks like this. You will put that in like a wall to protect some radioactive materials from you. And also I mentioned the lead glasses like this one. And this was restricted materials all around the world. Because if you want to buy this one, the lead glasses, IAEA or Americans will know you want to do some bad and mean things. So they will watch you if you need to register what you want to do for these glasses. So you can put this in the hot sale, then do some bombs. So it's highly restricted all around the world. And for the X-ray shieldings, most of them are in the airport, like lead barriers or lead curtains. And some clinics, they have fashion lead glasses. You can have your teeth X-ray scans inside. Then those glasses can protect the environment from the radiation. And also your labs, there's maybe some warning signs like this one. I think when you went to hospitals, if you go in, the door will be closed, then the sign will be flashed. So like the X-ray machine, there's dose meters here. It's a warning sign. If the dose is too high, the sign will be alarmed. And also for the radiation signs. And this one is the environmental monitoring monitors to tell you in this room how how many radioactivities in your room. It's also usually in microsievert per hour. When this number is increased, please be aware and then go away. Okay, then for the next part is the nuclear power plants and accidents. I will introduce some. We have several units in Taiwan, nuclear power plants in Taiwan. The first one is Jinshan Nuclear Power Plant. There are 2 units in there. And the second one is Guosheng Nuclear Power Plant. And there's also 2 units there. And the third one is the Ma'anshan power plant. There's also 2 units there. And I do not want to say we had 4 nuclear power plants Roman, but it was perceived for 3 years. Then we'll see if it will be operated or not. So for the first one is a BWR, and I can share this later. So our nuclear installed capacity is 5,000 megawatt. So I don't know if you have the sense, but electricity generation is about 90%. So 20% our electricity in Taiwan are from nuclear, and other parts are from coal or gas or other new green energies. But this number here is not so high. Like for example, for French, their nuclear electricity generation is about 75%. So they have lots of backup for their nuclear industries. They can sell the electricity to their neighbors like Germany, like Spain. So French make a lot of money from nuclear energy. So our nuclear energy and our nuclear power plants have 2 types, PWR and BWR. I think for the example, it's good for you to understand. Here is the BWR. So it's the reactor. We put the fuel here. So the heat here, then we will boil the water into vapors. Then vapor will go to the steam generator. Then another part, the water will be boiled again. Then the steam will push the turbine. Then have the generator have the electricity. So we generate electricity. So the radioactivity will stay in the first loop. It will not go out. So here, then go back, and again. So this second part is very clean. It's PWR. But for the BWR, you see there's only one loop. Put fuel here, then boil the water into vapor, and go to the turbine. Then go back from the condenser, then go back. There's only one loop. So the BWR, the systems are all contaminated. It means they are all radioactivity. So you will see. Maybe you will ask why we do not use PWR only, not use BWR. But the PWR, they have their disadvantages, like the steam temperature here is very high and the pressure is very high. So your construction cost for those is very large. So lots of people will just choose the BWR, not the PWR. Okay, so it's the difference here. PWR has 300 temperature higher and in pressure. So BWR and PWR, they are all around the world. And for this bird view of the Jinshan nuclear, the reactor was inside those 2 buildings. This unit 1 and this one is unit 2. The reactor was inside. So the containment is different from Ma'anshan. Ma'anshan nuclear power plant, if you go to Lüdao, Kending, you will see from the far distance, you will see a dome along the coast. So it's the containment building, these 2 units. Okay, the nuclear power plants in Taiwan, Jinshan, Guosheng, and Ma'anshan. the Jinsan is already 73 years old, so it will need to be decommissioned in this year. Not in this year, in 2018, but in this year, 3 years later, 3 years before, we need to submit our decommissioning plan for the Jinsan in this year. So these are all undergoing nowadays. The Taipower will submit the DP to the AEC in the end of this year, in the end of this month. So we can see if we, in 2018 and 2019, Jinsan maybe will be decommissioned. So for the north part of Taiwan, there's only Guosheng nuclear power plant still alive, but they will be decommissioned in 2018. So, not 2018. Three years later, it will be decommissioned plant will be ready. So in the north part, if after 2023, north part, these two nuclear power plants will be finished and decommissioned. So we just rely on the Ma'anshan nuclear power plant. But I don't want to emphasize too much political issues here. So we do not know if we have these two, if we do not have those units, the electricity may be enough or not enough in Taiwan. We can see that, and you can see that. And for the Ma'anshan nuclear power plant, it's a very high megawatt electricity generators. So it's very new, so we do not worry about that. But I think you can see that 2025 is only 10 years later. So after 10 years, the nuclear power plants in Taiwan will be decommissioned. So I do not know if the Roman nuclear power plant will be start up or not. And for the concept, you see the website, so you can understand. For the this one is for the PWR. For the PWR, the water here then get the steam generator, then push the turbine, then have the electricity. But here is from the foreign countries. They have the have a cooling tower. It's very large. But in Taiwan, we don't have that. We just use the condenser to condense the steam into water, and we do not have that. In my opinion, I think it's very obvious for you to tell it's the nuclear power plant. So the Taipower do not want to have this image, so they don't have the cooling towers. So for the PWR, I think you know that. And PWR, no. For the PWR, the vapor come out, then push the turbine, have the electricity out. Then those steam will be condensed again. Then through the pumps here, then pump into the reactor again. So the nuclear power plants make sure these parts are in control. Okay, PWR is the same, except they have the steam generator. Okay, so in the nuclear power plants in Taiwan, we have AECs. They have monitorings all around Taiwan. So for the AECs, they monitor all around Taiwan to tell you the radiation background for you. So like in Taipei's are here. It's 0.058 here. So the real-time monitoring, so you can see from the website to figure out which part is higher. Okay, for the nuclear power plants, I will introduce some accidents. These three are famous all around the world. The first one is USA, the 3 Mile Island, happened in 1979. I do not want to tell the detailed problems here. So it's caused some partial nuclear meltdown. In the RPVs, there's meltdown for the fuels. It's caused by valve failures and most part of that, human factors. If the operators ignore valve failures, the system will be shut down safely. But the the operators there just have a wrong determination for the operation. So which cause those partial nuclear meltdown. And another one, very, very horrible one, is in Russia, Chernobyl, 1986. This one is not regular commercial reactor nuclear power plants because they don't have containment buildings. So their reactor just in the environment. So and also they have unsafe operations. They are told they are safe. Maybe they are doing some secure researches for the bomb. So their operation is not safe. And the last one in 2011 is Japan. It's like Fukushima. And the earthquake for the power plant is not caused big damage because after the earthquake, the power plant just shut down immediately. But the most part is the tsunami. The tsunami flooded in the nuclear power plants and destroyed the generators. So I will show you two videos. The first one is the Fukushima nuclear power plant. I will just show you two examples of nuclear accidents. And for the accident, nuclear power plants are very horrible. So lots of countries after the Fukushima, they just want to decommission all nuclear power plants. But like in Japan, they reopened several units in this year or last year. So we need to consider if you want to continue using the nuclear power plants. Okay, then the last part is that the laboratory radiation safety is for you. So if you finish the lecture, you can make some experiments in XRD in NTUSD. We have two XRD machines. Here is the from Bruker D2 phaser, and another one is Bruker D2 Discover SSS multi-function. So I think maybe this one you can operate by yourself. So you need to realize how to protect yourself from the radiation. Okay. You all know that analytical X-ray devices are important tools in various areas, especially in material science and engineering. But X-ray diffraction equipment (XRD) are very dangerous, and the operators of this equipment must become complacent or overconfident about the potential damage of the X-ray beams. But for the first user of you will be afraid of the X-rays. But for the operators, they will just say it's not so serious. It's very simple. We just put the sample here, then we count. But do not have those mind because dangers are around you. So when high energy electrons strike an anode in a sealed vacuum, X-rays are generated. So X-rays are electromagnetic radiation. It could emit very far distances and cause ionization. And XRD could be hazardous. Before you use the XRD by your own self, detailed instructions on the operation, hazardous and radiation safety features of a specific analytical unit must be provided by the owner of the equipment. So the owner of the equipment is chemical engineering, not material science and the engineering divisions. So you must follow the instructions for the operators. So before starting, make sure you receive specific instructions on the unit safe operation from the authorized personnel responsible for the unit. So units responsible persons are here. Professor Jin Zhu and Professor Yiwen Yan are the authorities for the XRDs. And also you can reach for help from Ms. Yin Wu and Mr. Wu Jia for the detailed operation. Okay, I just informed this person are retired. So delete that. Just reach Ms. Wu for your detailed operation or troubleshooting. Don't try to open the machine by yourself, please. Okay, potential health for the XRD, they have primary beams, scatter radiation, and leakage. So the most harmful is from primary beams. So do not open the XRD by yourself. It's easy to remember. And overexposure to X-rays can result from direct exposure or primary beam. So here I do not put more examples for the hazardous of X-rays. Some people died in the operation of X-rays because they avoid some security procedures and have some overdose exposure. But that case is very rare. And again, I will remind you again, ADARA, just remember that, as low as reasonably achievable. And the regulators recognize that it's an individual worker's responsibility. So it's your responsibility to perform tasks on a daily basis and as low as possible. So it's your own possibility to make the radiation exposure as low as possible. But do not tell your professor you do not want to do the experiment because you need to graduate. And workers are responsible for knowing all hazardous and safety practices. So I think our operators here will remind you all hazardous and safety practices. And remember, only trained or authorized persons may use or install, especially maintain or repair XRDs. Do not try to do that by yourself. And remind you again, the annual dose limits in Taiwan, I think you belongs to public. So your effective dose is 1 millisievert per year. And for your eyes, 50 millisievert. And your feet and hands is 50 millisievert. But for Ms. Wu, she's limitation is higher. 50 millisievert per year or 100 millisievert in 5 years. So just remember that they should do all the responsibilities. Don't do that by yourself. So for myself, I will put the samples there and run away. And because usually it takes you 15 to 20 minutes, then please come back, change the sample, and then run away again, if possible. Some experiment you need to be there because the angle is small, so time is short. So safety tips to prevent overexposures. Know locations of the radiation. So make sure you know the primary beams from the XRD, and do not put your body parts into beam heads, and inspect shielding, or no maintenance work when beam is analyzed. So when it's working on, do not maintain that. And monthly safety clocks and survey units were moved or being realigned. Also, this is our conclusion. Radiation is part of our life and also a resource from nature. But radiation is a two-edged sword, make our life better or maybe worse. So people are needed to well trained before or while utilizing nuclear energy technologies, and should be aware of the importance of radiation safety. So make sure you are all safe in your lab and successfully get your master's degrees. Thank you very much.